Hey, what's going on, guys? This is Dead Cool, hey, yeah, yeah. And you'll figure out what this is for in a minute. But yes, this is today that I'm creating a new series called Dead Cool Science. This is my fourth time trying to make this video. Fourth time! Snippy. Yes, today we're going to be focusing on the subject of gravity. Gravity or gravitation is a natural phenomenon. I don't know. By which all things with mass are brought toward or gravitate toward one another, including objects ranging from atoms and photons. Photons are light particles, and light particles are essentially just light, or the gateway to heaven, to photons, to planets, stars and galaxies. Since energy and mass are equivalent, all forms of energy, including light, cause gravitation. You see, light does have mass, but it's a really small bit of mass. It's almost insignificant. Well, it's insignificant, but anyway. Cause gravitation and are under the influence of it. On Earth, gravity gives weight to physical objects. Alright, cool. So you see this battery? Right. Far away distance. It fell toward my hand because of gravity and weight, which we'll also be getting to in a later video, or in a different video. Anyway. And the moon's gravity causes the ocean tides. That's true. Well, obviously it's on Wiki. The gravitational attraction of the original gaseous, matter present in the universe caused it to begin, bear with me here, coalescing, forming stars, and for the stars to group together into galaxies. So gravity is responsible for many of the large-scale structures in the universe. Gravity has an infinite range, although its effects become increasingly weaker on farther objects. Okay, so it says here also, gravity is most accurately described by the general theory of relativity, which was proposed by Albert Einstein. Proposed by Albert Einstein in 1915. See, told you. And I just read it there. But nevertheless, shish. I think there's a Yeti in my house. Anyway. Which describes gravity not as a force, but as a consequence of the curvature of space-time. We'll get into that in a different video as well. Caused by the uneven distribution of mass. The most extreme example of this curvature of space-time is a black hole. We'll get to that in a different video as well. From which nothing, not even light, can escape. Yeah, okay. I'll just give you this short version of a black hole. Okay. So, okay. See this battery? See this clock? Okay. Okay. Now, must be hard to see, but okay. See the clock? If this clock was to go into the event horizon of a black hole, or the outer ring of a black hole, okay, it'd stop. The clock would stop even if it had this battery in it. And that is why a black hole is inescapable. Well, not really. But yeah, the event horizon is the outer ring of a black hole, which time cannot even escape. So, where was I? Oh yeah, most extreme black hole, from which nothing, not even light, can escape. Once past the black hole's event horizon, however, for most applications, gravity is well approximated by Newton's law of universal gravitation. We will get into that in a different video as well. See, I'm covering all subjects here. I might even do math, don't know. Which describes gravity as a force which causes any two bodies to be attracted to each other with the force proportional to the product of their masses and inversely proportional to the square of the distance between them. You see, I can't really sum that up right now, but we'll do it in a different video. And I might have to make this a two-parter, I don't know. The earliest instance of gravity in the universe, possibly in the form of quantum gravity. Can you see? I'm just going to, fun little fact here. Quantum foam is the smallest thing that has ever been discovered in the universe. I think it's smaller than an atom and a molecule and a particle. It's really small, smaller than anything. So that's why it's called quantum foam, I think. In the form of quantum gravity, supergravity, or a gravitational singularity. 1036, I'm not sure what 36 means, but E equals mc squared. Has a little 2 up above it, which means squared. And if it's got a 3 above it, I think it means cubed or cubic. Don't know. But yeah. So 1036, again, I don't know what it is. To the 36th power, maybe? Times weaker than the electromagnetic force, and 10 to the 29th power, I think, I don't know. Times weaker than the weak force. I'll get into those things in a later video, or a different video. As a consequence, it has no significant influence at the trajectory / or like little brackets orbit of astronomical bodies. We'll get into that in a different video as well. For example, gravity causes the Earth and the other planets to orbit the Sun. That's because the Sun is so massive, like massive. It has the biggest gravitational force of any of the planets in the solar system. Jupiter has the second strongest gravity in the solar system. So yeah, like the planets just orbit around this Sun. Okay, so it says that my fist is the Sun. Right, my fist is the Sun. This is the Earth. We're probably not this close to the Sun, but it just keeps circling around it, and not at this speed. It probably goes like this speed, like probably like 10 times slower than that. Maybe 5 times, don't know. Yeah. What was it? Oh yeah. It also causes the moon to orbit the Earth and causes the formation of tides, the formation and evolution of the solar system, stars and galaxies. The earliest oh yeah, wait, we already covered this, I think. No, we didn't. The earliest instance of gravity. No. The earliest instance of gravity in the universe, possibly in the form of quantum gravity, supergravity, or along with ordinary space and time, developed during the Planck epoch, up to 10-43 seconds after the birth of the universe. Oh. Possibly from a primeval, don't know, state, such as a false vacuum, quantum vacuum, or virtual particle. I'm not entirely sure what they are, but we'll cover them in a different video. In a currently unknown manner, attempts to develop a theory of gravity consistent with quantum mechanics, a quantum gravity theory, which would allow gravity to be united in a common mathematical framework, a theory of everything with the other 3 forces of physics, are a current area of research. Yes, that is a thing. But yes. And there's also the whole thing about the history of gravitational theory, but I don't think we'll get into that in this video. Yeah, probably won't. Oh, nice picture. Sorry. But yeah, guys, that does it for this video. Hope you guys have enjoyed. Please leave a like if you like this series. If you liked it, please leave a like, subscribe, or comment, whichever one you want to do. Even if it's just watch the video. Yeah, even if it's just watch the video. That's good enough for me. But yeah, guys, and have a deadly day.